In this video, we're going to do a range of different topics from statistics. I've written a question here, and it says the table below shows the length in millimetres of some worms found in Steve's garden. So we've got the length in millimetres and then the frequency. This is continuous group data. So we can see that we've grouped these worms from 0 to 5 millimetres. So the class is from 0 to 5. This one's 5 to 15, 15 to 25, 25 to 45, 45 to 75. We can also see that these are unequal classes. So this one is 5, this one is 10, this one is 10, this one is 20, and this one is 30. We have the frequency here, and we're told the minimum length and the maximum length. So the shortest worm and the longest worm. We're going to do 6 different things with this data set. We're going to look at an estimated mean, cumulative frequency chart and curve, including estimates for the median and IQR, a box plot, a stratified sample of 20, which will be stratified by length, a histogram, and a frequency polygon. So let's start off with the estimated mean. This is an estimate because we don't know how long these 12 worms were. We just know that they were somewhere between 0 and 5. What I'm going to do is introduce 2 more columns. The first one is going to be the midpoint. Sometimes you might see this being written as X. I'm just going to call it M, which is going to be the midpoint. So if I put here M, we want the midpoint of this class. The midpoint of 0 and 5 is going to be 2.5. If we look at the midpoint here, that's going to give me 10. The midpoint here is going to give me 20, the next one is 35, and the next one is going to be 60. Essentially what we're saying is all of the worms, all 12 worms in the first, we assume to be in the middle, the 2.5 millimetres long. These 20, we assume that they're all 10. What we now do is the frequency multiplied by the midpoint, or if you like, fx, the frequency times by x. So I'm going to have 12 times by 2.5, so 12 times by 2.5, that is going to give me 30. What this 30 is the total length of all of the worms if I added them up in the first class, assuming, of course, that they're all 2.5. Then we're going to have now 20 times by 10. That means that the worms coming from the second class will provide us with 200 millimetres of wormage. Or for want of a better description, whatever you'd want to call it. 9 times by 20 is 180. 11 times by 35 is going to give me 385. And then finally 8 times by 60 is going to give 480. We need to sum this up. If we sum these values, this will give me the total length of all of the worms added together. We use the sigma notation, which means sum of the frequency times by the midpoint. So if I work that out on a calculator, I'm simply going to add these up. So we'll have 230 plus 180, then we're going to have plus the 385, and then we're going to have plus the 480. So taking a bit of a shortcut there, we can see that gives us 1275. So 1275 is the total length of all of the worms if we put them in a long line. We're now going to look at the sum of the frequency. We know from before to find a mean, we find the total items added together and divide it now by the number of items. So the number of items in this particular case is the frequency. 12, 32, 41, 52, 60. So all we need to do now, as before with any mean, we take the sum of the frequency times by the midpoint and divide it by the sum of the frequency. So our estimated mean, and we can jot this down, will be equal to 1275 divided by 60. And this will give me an average length now of the mean value of the length of each of these worms. So let's divide this by 60, and that's going to give me now 85 over 4, or 21.25. So we can say this is 21.25, and that will be millimetres. You might be asked to round your answer. Let's round this to 3 significant figures. So round into 3 significant figures. It's going to be the 2 that's potentially changing. We round up, and now correct to 3 significant figures, this is going to give us a mean length of 21.3 millimetres. So that's the first part done. We're now going to look at a cumulative frequency chart and curve, including estimates for the median and interquartile range. So IQR is the interquartile range. When we see the words cumulative frequency, we think running total. So all I'm going to do here is introduce another column, and this is the cumulative frequency column. If we think about this now, we have 12 worms that are going to be 5 millimetres or less. If I think about how many worms I've got that are 15 millimetres or less, it's going to be these two added. If I've got 25 millimetres or less, it's going to be these three added. If I think about 45 or less, it's those added. So all we do is add these up. This is a running total. So we get to 12, 32, 41, 52 and 60. So we can see all 60 worms were 75 millimetres less. There were 52 worms that are 45 millimetres less, 41 worms 25 millimetres less, 32 15 millimetres less, and 12 5 millimetres less. So this is our cumulative frequency chart, and we now need to plot this. This is going to become my cumulative frequency curve. If we just look at this, we've got up to 75. This one only goes up to 70, so I'll just tag it on just here. That's no issue. We need to label this up, and I'm going to write now on the axis down here that this is going to be the length in millimetres. So the x-axis, or the horizontal axis, gives us the length, and cumulative frequency will be on the vertical axis or the y-axis. So this is our running total. When we plot the cumulative frequency curve, we plot at the end of the class interval. So by the end of the 0 to 5, I've got 12. So what I do, I find 0 to 5, and then I go up, and that gives me now 12. So I can put that first dot on. By the end of the class now, where we've got 5 to 15, we can see it's 32. So I find 15, which is just here, and then I locate 32, which is going to be just there. So that gives us the value. We're now going to look at the next one, and the next one is going to be 25, and we've got 41. So we need the end of this class, which is 25, and we have 41. So there's 25 and 41. That can go just there. The next one we've got now on here, 45 and 52. So we locate 45 and we read up now to 52. So there's 45, this line just here, and 52 looks to be about there. So I can put that point on. The end of this one, we've got 75 and we've got 60. So let's just put that about there, so we know that that's going to be our 60, and we got 75 down here. I now need to connect this up. When we connect this up, it's going to be a sweeping curve. This isn't going to be fantastic on the computer, but hopefully it will give you some idea of what you're going to do. So we have a sweeping curve rather than a set of straight lines. It is possible to do a set of straight lines, but it won't give you as accurate a prediction or an estimate on this. So we do this with a curve, and it will look something like so. So we'll come round to that point, and then finally we will come up now, and by this point here we've seen all of the 60 worms in our chart. So it will come round, let's do something like that. That's not brilliant, but again, hopefully it gives you some idea. Let's just tidy that up of what the cumulative frequency curve will look like. So let's put that dot there, and it'll do something like that. So that's our cumulative frequency. It's a running total. What we're now going to do is look at an estimate for the median. We need the interquartile range, so we need the upper quartile and the lower quartile. When we're finding the median, we split the number of items in half, and we read off that value. A common error here would be to be saying now that the median is 30. The median is not 30, it's taken off the 30th worm. So if we want the median, what I'm going to do is take now off the 30th worm, that's the cumulative frequency, and I'm going to drop the line down and read off. That looks to be approximately 14. So what I'm going to say then is that the median, and just write it here, median is approximately 14. Remember, that's an estimate. I'm now going to look at the upper quartile and the lower quartile. If we divide 60 by 4, that's going to give me 15. So the lower quartile will be read off the 15th worm, and that looks to be about 6. So let's go ahead and write that on. So that will be read off the 15th worm. Let's put that on. So on here we've got 60, so we can say now the 15th worm is going to give us now approximately 6 millimeters. So this now is going to be the lower quartile. So what the lower quartile tells me is that 1/4 of these worms now were less than 6 millimeters long. Let's now look at the upper quartile. If the lower quartile is taken on the 15th, we just have to multiply that by 3, and that will give us 45. Or you can say 3/4 of 60 is 45. We read across the cumulative frequency curve, we drop this down, and that gives us 31. So this now is the upper quartile. So let's write this on. 31 is my estimate for the upper quartile. So UQ, upper quartile. Sometimes you might hear these being called Q1, Q2 and Q3. Generally speaking, we use lower quartile, median and upper quartile. So what this tells me is that 3/4 of the worms were approximately less than 31 millimeters long. So let's now work out the interquartile range. The interquartile range is the upper quartile subtract the lower quartile. So writing this in, IQR, so let's write this in, the IQR is going to be equal now to the upper quartile minus the lower quartile. And if we look at that now, we're going to have the value 31 minus 6, which gives us 25. So 31 minus 6, which is 25. This tells me the most representative 50% of this data set, so 50% of the worms, had a variation of 25 millimeters. The smaller the interquartile range, the more consistent and less variation we have. So we can say now that that as a measure of spread would say that these worms are very similar in size. If we're making comparisons, we could say that the median was the average. So for example, if I had another set of worms and the median was 29, we could say the other set on average were longer. So that is a cumulative frequency curve. These are estimates now for the median, the quartiles, and we looked at the interquartile range. What we're now going to do is draw a box plot. You can draw a box plot off the bottom of this cumulative frequency curve. What we need to consider though is that we have the other two values. So on here I'm going to put now the lower quartile. So we've got the lower quartile, which is going to be 6. We have the median, which is going to be 14. We have now the upper quartile, which is going to be 31. This makes our box. So this is the box right here, so we can draw the box. We're now interested in the other two values. That is the minimum length, which is the lowest value of 2, and the maximum length, which is the highest value, which is 74. So if we put this on, that looks to be 2 just there. Let's move that across. That's 1. Let's put 2 on. So just moving that across, 2 is the lowest value, which can go just here. And then on the next one, our highest value was 70. What did we have? 74. And that's going to be somewhere out here. So let's go ahead and do that. So we can see with this one right here, our range is huge. The interquartile range is a better measure of the variation or the spread of the data. So that's what my box plot looks like. Again, if we had to compare them, we would consider now the median, the interquartile range, and to some extent the entire range. The disadvantage of using the range is that it includes potentially what we call outliers, so freak results. With this one, we've done that one, and that's a box plot. So if you want to label this up, this is going to be the smallest value. So smallest value, writing in, so smallest. We have now this value right here, which is going to be the lower quartile, the median. We have the upper quartile, and then we have the largest value up here. So there's our box plot, largest value. I like box plots. They give us a good visual representation now of the distribution of this data set and any others that we put on the same size scale. There is a full tutorial on box plots in this same series. So that's done. The next thing we're going to do is a stratified or stratified sample. And we need our sample to be 20. A stratified sample is representative of the population. So for example now, if I wanted to collect information about these now, and it was about the food that they ate, then it's no good if I had, let's say, 20, to take all 20 from this second particular layer or strata. We would call this a layer or strata. I want it to be representative. So what I do is take now the sample size, I divide it by the population and multiply it by each of these layer sizes. And that tells me how many of these worms should be in the survey that I want to carry out. So we know that this equals 60. So what I'm going to have here is the following. I'm going to have now 20 of the 60, and I'm going to multiply that by 12. That tells me now how many of these worms I want in my survey. Now you can break this fraction down. 20 over 60 is 1/3. In general, what we write is that the sample size divided now by the population, so population multiplied by the layer size, will give us now how many we need in each. As you'll see shortly, we might need to make some adjustments. So this is the layer or the strata. The next one, we're going to get 20 of 60, or 1/3, multiplied by 20. On the next one, we're going to get 20 of 60 multiplied by 9. That will tell me how many worms I need from this particular class. Then the next one will be 20 over 60 multiplied by 11. Then we're going to have 20 over 60 multiplied by 8. So let's do the easy ones. 1/3 of 12 is going to give me 4. 1/3 of 20, that's not going to be nice. That's going to give us now, what's that, 16.6, and so on and so forth. So let's let's just do 20 divided by 3. So 20 divided by 3, what's that give us now? 6.6 recurring. So 6.6 recurring. If we look at this, 1/3 of 9 is going to give me 3. This one right here, 1/3 of 11, let's write that in. So 11 divided by 3. So if I have 11 divided by 3, that's 3.6 recurring. So let's put that in. 3.6 recurring. And then this one, we've got 1/3. Let's put this in. 1/3 of 8, or 8 divided by 3. And that's going to give me on there 2.6 recurring. Right. If we think about this now, we can't have 2.6 recurring. We can't have 3.6 recurring. What we need to do is ensure that when we have our sample, there are 20. If I rounded all of these up, if we look at these, if I rounded them up, that would be 4, that would be 7, that would remain 3, that would be 4, and that would be 3. If I add these up, I've got 11, 14, 18, 21. So right here, I've got now 21 in total, if I round all of these up. So 11, 14, 18, and then 21. We can't have 21, so we need to make some adjustments. So if I look just here, I'm going to round this one up. We've got quite a lot in this particular category right here, or layer or strata. This is going to be rounded 7. So I'm definitely going to keep the 4. I'm definitely going to keep the 7. I'm definitely going to keep the 3. And now I have to decide which of these I'm going to round down. I'm going to round this one down to 2. If we look at it now, we've only got 8 of these, we've got 11 of these, so I'm going to round this down now to 2. So that will be rounded up to 4, this will be rounded down to 2, and that will give me the 20 required. So we're going to have 4 of these, 7 of these, 3 of these, 4 of these, and 2 of these. 11, 14, 18, 20, and that gives me now each value that I need, or 4 from the first layer, 7 from the second, if I want to take a stratified sample. A stratified sample is proportional to the size now of the layer. So for example, now this is proportional. We needed a third of the whole data set, so we have a third of the first category. So okay, that's a stratified sample. Let's now look at a histogram. Histograms, the skill level of histogram has increased. With histograms, we have areas. So the area of the bar is proportional to the frequency. We're just going to do a little here, and what we're going to have now is the following. Frequency density. So what I'm going to have is a frequency density, and we're going to plot this. Frequency density will go up the y-axis, and then the class widths along the x-axis. Frequency density is defined as frequency divided by class width. So if I introduce a frequency density column, what we can do is start to work these out. So let's go ahead on here. So here we're going to have FD, frequency density. So just popping it in here, so frequency density. So I'm going to do the frequency divided by the class width. The class width is 5, so we need to do 12 divided by 5. So 12 divided by 5 is going to give me 2.4. On this one, the frequency is 20. The class width, sometimes people say this is 15. It's not. The class width is 10, and that's going to give me a frequency density of 2, or 2.0. What we have here now is a frequency of 9, and we have a class width of 10. So on this one right here, we need to do 9, which is a frequency divided by the class width. The class width is 10, and that's going to give me 0.9. That's my frequency density. This one just here, we have now a class width of 20. So we've got now 11 divided by 20, which should give me 0.55. Let's just check that. Check my brain isn't going mad. 11 divided by 20, that's the class width. And that will give me my 0.55. So 11 divided by 20 is equal to 0.55. And then finally, this one is going to be 8 divided by 30, which is what, 0.24. Let's just check that. 8 divided by 30, which is the class width. And we get on there 0.267 and so on and so forth. So 8, let's just check I've got that in there. 8 divided by 30 is going to be 2.6 recurring. What I now need to do is draw this on a histogram. So here are my classes. I'm going to label this up, and I'm going to say that this is the length. So if we look at this, we can say now the length in millimeters, and this is going to be the frequency density. So this is not a bar chart. Sometimes students do bar charts. This is not a bar chart. So what I'm going to have here, and I can decide the scale, I'm going to have now on here, I'm going to have 1, I'm going to have 2, and I'm going to have 3. I could have made that more accurate if I wanted to, but this should be sufficient. So I know that the first one from 0 to 5 is going to give me 2.4. So let's go ahead now and put this on, and our first box here is going to give me a frequency density of 2.4. So if we go ahead and do that, 2.4, and we need to make sure that this, and I'll put that just there, that's 2.4, ends at the end of this class interval. That's from 0 to 5. So what we have is a frequency density of 2.4 and a class width of 5. If we look at the next one, we have now a frequency density of 2, so we need to go from 5 to 15, and that will be 2. So 2 is going to be just here, so let's put that on. That's 5, that's 15. So we end up now with the second bar looking something like that. Let's put that nice and neat. So that looks pretty good. The next one, we've got a frequency density of 0.9 and a class width of 10. So 0.9, and we need to go from this point right here, and that will take me out to 25. So that looks somewhere like so, and that will take me to 25. And that's 0.9. If we look at the next one, 0.55, and that's from 25 to 45. So 0.55 is going to be about there, and that's 25 to 45. So that looks pretty good to me. And then finally now we have on here 45 to 75. 2.6 recurring. So 45 to 75, 2.6 recurring looks to be about there, and we'll take this out now to 75, and this will look something like so. So what we have then is a histogram. These are unequal class widths. So there we go, that's what we have, 2.6 on here, that's our frequency density. Let's just check that one. I think I've got that. Let's go the other way on that side, 0.266. That's why it looked a bit strange. So let's put that on. I was going to say that didn't look fantastic. 0.266. I think, yeah, let's put that on. Hopefully you'll be able to see, if you make a mistake like I just have, 0.26 recurring. So you can see quite clearly that shouldn't be like that, and we'll just change this over. So if we get a shot of that one and put this on, let's do that. So 0.266, so 0.266 looks to be, give or take, about there. So that looks a bit better. There we go. So that's a more accurate histogram. So this gives us an unequal class width. Now, sometimes we'll be expected to read from a histogram. If we look right here, we've got this frequency density of 2.4, and I'll just put it here. This is 2.4, and we've got a class width of 5. Remember, this is 0 to 5. If I multiply the frequency density by the class width, I'm going to end up with 12. That gives me the frequency. That gives me the number of people, or in this case, the number of worms that were in here. If I look at this one, I've got 2. And the class width is going to be 10, this distance from here to here. 2 times by 10 is 20. If I kept going through this, we would get the frequency back. We can see 12 and 20. If we look at this and just rearrange this equation, what we've got then is multiplying both sides by class width. Class width multiplied by frequency density gives us the frequency. We could also say that class width divided now, so on this one I can do the class width is going to be equal to the frequency, let's write it this way around, divided by the frequency density. So if you can do this particular one, and remember this, that frequency density is frequency divided by class width, you can move these around, rearrange them, and then find other values. So that gives me my histogram right here. So if we look at this, this is 0.9, so this one right here, 0.9, and this is going to be a width of 10. Again, don't say that it's 25, you can see it's a width of 10, so this would be 0.9 multiplied by 10, which gives me 9. And of course, if we look in our third box, we know that we had 9. So this is really important that you know it, and then this one, class width multiplied by the frequency density, is the frequency. The main take-home point with histograms is that they're proportional. So this now gives us, instead of just a bar chart, the area is proportional to the frequency. These are examples of unequal bars or unequal widths, and it would be seen as a slightly higher skill. Okay, let's now move on to the next thing. So that's a histogram. Again, you might want to label it up. I put frequency density and length in millimeters. And let's now go on to the last particular thing, which is going to be a frequency polygon. So let's go for this now. Frequency polygons are plotted at midpoints. We simply find the midpoint of the class, we write it down, and then we plot these points. So we can see that the midpoint of this one is going to be 0.25. We know the midpoint of this one is 10, 20, then we had on this one 35, and then we had this one, which was going to give us now the 60. We saw this from before, so this is what we plotted earlier. So all I need to do now, and just looking at the scale, this scale isn't brilliant, but it just gives us some idea. I'm going to plot the first one, and that's going to be now at 0.25, and we're going to have a frequency now of 12. So find 0.25. 0.25 looks to be about there, and then I'm just going to go ahead and plot this. So these are being plotted at midpoints. If we look at the next one, the midpoint is 10 and we need 20. So let's find the midpoint, that's 10, and we need to plot 20. So that is just there. The next one needs to be plotted at the midpoint, which is 20, and that has a value of 9. So let's find 20. There's 20, and it has a value of 9. And if we look at the next one now is going to be 11, a value of 11, and that will be plotted at 35. So let's put that on. 35 is just here. 11 looks to be about there. And then finally, what do we have? We have 60 and a frequency of 8. So let's do that. 60 and the frequency is going to be 8, which looks to be there. So all I need to do to complete this is connect this up. So let's go ahead and connect it up with a straight line between each point. This is a frequency polygon, and all we would do is go ahead and label it. So it looks something like that. On the x-axis or horizontal axis, we would say that this is going to be the length. So we've got the length in millimeters, and we're going to say now that this is going to be the frequency. So frequency just here. So there we go. That now is a frequency polygon. So we've been through all of these now. We've looked at an estimated mean. We've looked at cumulative frequency chart and curve. We've looked at box plots, stratified sample, histogram, and frequency polygon. Do check your work. As you saw on this one, I slipped up, looked at this and thought, hang on a moment, that's incorrect, and went back and sorted it out. If we look at some of the other questions, just clearly setting each one up will give you exactly what you need. So 6 different skills, and the vast majority of these are seen to be higher level skills.